Hi everybody, this is Dr. Nageswara, Assistant Professor of Physics, SRR and Severe Government Degree College at Autonomous Vijayawada. We are discussing about different methods to produce low temperatures and also different applications of low temperature physics. Today we will discuss about some of the properties of substances at low temperatures. We know the properties of substances changes at very low temperatures when compared with the properties of substances at room temperature. So because at very low temperature, the properties of molecules changes, the alignment of molecules changes. Due to this, it exhibits some of the peculiar properties. For example, at 90 Kelvin, the most of the chemical reactions are ceases to take place, so that we can preserve the materials, maybe it is the animal or vegetable matter, without purification at this such low temperatures, like in refrigerated system. The second property is the materials like cotton and wool exhibit the properties of fluorescence. You know, different properties of materials like fluorescence and phosphorescence. When some of the materials exposed to light, it emits some of the light, so that is called fluorescence. If it is exposed to light, after removal of this light also, it experiences emit light. That is called phosphorescence. For example, radium stickering we will observe in a real life. So at low temperatures, the cotton and wools also exhibit this property of fluorescence. And at a low temperature, that is at nearly 83 Kelvin of temperature, LED loses elasticity and attains plastic state. We know in case of rubber also, when at a very low temperature, it loses its elastic property and acquires or attains plastic property. So at that such low temperatures, it looks like brittle, so it can break easily. So rubber cooled to such a low temperature breaks into pieces just like a cork when hammered. So that at very low temperatures, the material loses its elasticity property. Now all substances, the atomic heat tends to become zero at absolute zero of temperature. Of course, this is also called third law of thermodynamics. According to third law of thermodynamics, the atomic heat capacity is zero at capital T is equal to 0 Kelvin. Elements like oxygen, actually those are not paramentic materials at room temperature, but at a low temperature, that is very low temperature, the materials like oxygen turn into the paramagnetic material, so that whose properties of magnet are changes. The magnetic materials are the magnet of the susceptibility, that is also called magnetic susceptibility of the paramagnetic materials, whose is inversely proportional to temperature. That is according to the Curie's law. So the magnetic materials are magnetic susceptibility of certain paramagnetic materials varies inversely as the absolute temperature and the region of low temperatures in case of oxygen also. So we know cryogenic engines we are using nowadays in the rocket system. So cryogenic is nothing but the study of low temperature production. So is the production and the behavior of materials at very low temperatures. Nowadays, it have very much importance in the uses of engine prepared in the rocket systems. At low temperatures, some of the materials changes its properties very rapidly, so that its properties also changes. Such phenomena are superconductivity and superfluidity. So superconductivity and superfluidity have traditionally been thought of as phenomena that occurs only at very low temperatures. Now we will discuss about what is superconductivity and what is superfluidity. When a substance whose electrical resistance goes to zero at very low temperature, its conductivity is infinity. Such phenomena is called superconductivity. We know nowadays we are using for the electrical conductors as materials such as copper, aluminum, etc. So even though copper and aluminum have low resistance, it has some resistance. So that we are losing some heat energy, some electrical energy in the form of heat. We know the formula heat energy liberated, Q is equal to I square RT. When a resistance R increases, the heat energy Q also increases. So at such very low temperatures, the electrical resistance is zero, is nothing but the heat liberated at such materials is zero. It is nothing but we can get very less problems in the conduction of electricity. So that varies from the one substance to another substance, that is, of course, the temperature at which the resistance goes to zero in this superconductivity is called transition temperature. This transition temperature varies from one substance to another substance. For example, in case of helium, the transition temperature is 4.2 Kelvin. Superfluidity is nothing but when at very low temperatures, whose viscosity is nearly goes to zero, so that it act as a superfluids. So in which case, without being stopped by friction or gravity. So these are the some of the properties of low temperature materials. Thank you very much.